This question is asking to convert a system into a second-order differential equation by differentiating the second one. And at first, you might not know what this means, but let's rewrite this as the usual Newtonian notation. The first one is saying x prime is 4y. The second one is saying y prime equals to negative 4x. It's a lot easier to see than the previous one. And then it says you differentiate the second one. So if I differentiate this, we get y double prime equals to negative 4x prime. And let's see, y double prime. And then it says substitute x from the first equation. So yeah, once you have this x prime can be replaced by negative 4y, right? So you can furthermore rewrite this as negative 4 times x prime is replaced by negative 4y. And that just becomes 16y. So that just gives us a single second-order differential equation, which is y double prime equals to 16y. And that's not hard to solve. It's just you can rewrite this as y double prime minus 16y equal to 0. And then write the characteristic equation, which is r squared. There's no y prime, so there's 0r. And then minus 16 equal to 0. Whose solution is simply r equals to 4 and negative 4. And this means that y double prime, or this means y is equal to c1 e to the 4t plus c2 e to the negative 4t. And then in order to get the value for x, you have to plug this into the left side and solve this differential equation. Okay? So what you want to say is that, or actually this is easier. I think x is negative 1/4 of y prime. So to get the x, you can say x is equal to negative 1/4 of y prime. And since y is given as this thing here, I just have to differentiate that. And you just differentiate individually by using the chain rule. So first of all, when you differentiate e to the 4t, you get 4 times c1 e to the 4t, and this 4 comes down because of the chain rule. And when you differentiate this time the negative 4 comes down. And then you multiply negative 1/4 through, and the result is you get negative c1 e to the 4t, and then plus c2 e to the negative 4t. And that's the answer. So now we have this as the answer. And this will be the other answer. And in many cases, what you have is you might have an initial condition, x of 0 equal to something and y of 0 equal to something, and then you're going to get some equation for c1 and c2. So use that to solve for c1 and c2, plug them back in, and that will be your answer.